Okay, this lesson is on using the complement. It's not that you can use a complement, although I'm sure you're a very good math student. This is called using the complement. Okay, so let's go back to an example that we had used already, which was what is the probability of rolling greater than 7 with 2 dice? All right. And we had determined simply by counting, you could count by hand, that the answer should be 21/36. All right. Now, what if I wanted to know the probability that the total is less than 7? Notice it's not less than or equal to, it's less than 7. So that's all other possibilities. All right. You could start over and count up all of the numbers. Okay. So you could look at this total. You could take the probability that the total is 1. I'll just write the probability of 1 plus, you could add up, which is 0, by the way. You never get a 1. So I should probably start with a 2. The probability that you get a 2, the probability that you get a 3, the probability that the total is a 4, plus the probability that the total is 5, plus the probability that the total is 6. And if you count those up, you would see that for each of those, there are a certain number of ways you can get it. If you look back at the sample space, you would see there's only one way to get a 2, but that's 1 out of 36 possibilities. There are 2 ways to get a 3. There are 3 ways to get a 4. There are 4 ways to get a 5. And there are 5 ways to get a 6. So if you add all of those up, those all have the same denominator of 36. So we can add those up: 3, 6, 10, looks like 15 out of 36. But it would have been a lot faster to use the idea of the complement, all right? We could take the probability that the total is less than 7 is equal to 1 minus the probability that the total is greater than or equal to 7. Remember that 1 is really a 100%, all right? So we can take the answer for what they, if we already know what the probability of getting greater or equal to 7 is, I could simply have taken 1 minus the answer that we already knew, which was 21/36. And hopefully you know it's easiest if you make that 1 of 36 out of 36 and just subtract the fractions and get 15/36. All right. So we can say, using the idea of complements, that this, if E is the event that the total is greater than or equal to 7, then the book would call this complement, we would take the probability of the complement of E, all right? And that would give me the probability that the total is not greater than or equal to 7. So the complement of an event is to say that it does not happen, okay? So this would be the probability that E does not happen. So if we already know the probability that it does happen, we could simply take 1 minus that to find out the probability that it does not happen. Okay, so this gets us to example 5 in the book. So 25 balls are in a jar. We're going to not look and peek. 10 are red, 15 are blue, and we're going to pick 6. And we're charged with finding the probability that at least one of the 6 that we pick is red. Okay, so we could go about doing this the old-fashioned way, the way that we had learned in the previous sections. We could find the probability that exactly one is red. Let me actually say probability. I'll write in 1 is red. All right, and we could do that by saying, okay, we're going to pick. Let's see, we have 10 reds. So we could do it with combinations or permutations, but we could take the combination of the 10 red, and we're going to pick, let's see, let me pause very quickly and make sure I have my thoughts together. Okay, I think I have my thoughts together. Okay, so that would mean from the 10 reds, we can only pick one. And we would have to multiply that times the combinations of picking out of the 15 blue, we would have to have 5 of them be blue. Okay, so we would look at the number of ways that we could get 1 red out of the 10 times the number of ways we could get 5 blues out of the 15, and we would multiply those together, and it would give us the number of ways that we could draw those. And we would put that over the total number of 25 things, taken 6 at a time, all right? So that ratio would give me the probability that 1 is red. But it says at least 1 is red. So if 2 were red, that would be just as good. So to find out that 2 are red, we could take the combination that from the 10 reds, we could pick 2 of those. And then from the 15 blues, we would have to pick 4 of those. And that would be out of the total number of possibilities of picking 6 things from 25. Then that would give me the probability that 2 are red. And what would we want to do with those probabilities? We would want to add them up, because if 1 was red or 2 were red, we would have succeeded. And we would keep on going all the way down to the probability that 6 are red. And you can see how tedious that would be to do all of those computations, all right? So what would be easier to figure out is the probability that none are red. So let me actually change to the color blue here, probability that 0 are red. Okay, now this is the same as the probability that all 6 are blue. Okay, so if we want to find the probability that 0 are red, it's the same as finding the probability that 6 are blue. And this would mean that we kind of lose, all right? This is not what we want to have happen. We want to get at least 1 red. So we would lose if this were the case. But if I know the chances of losing, then I can easily figure out the chances of winning. So the book quickly realizes, okay, if we want to find this, we can take the number of, we have 15 blues that we can choose from, and we need to get 6 of them. So that would be the numerator. And for the denominator, we would need to take all 25 balls and pick 6 of those, because that would be the total number of ways we could select the balls. And they end up with the probability of this being, the probability of getting all blues was 13 out of 460. So if I wanted to find the probability of getting 1 or more red, instead of looking at getting 1, 2, 3, 4, 5, and 6 reds, I can simply take 1 minus the probability of not getting any reds. Okay, and then we could say that's 460 over 460 if we want to get an exact answer, minus 13 over 460. So that would be 447 out of 460. It could reduce. When we're talking about probabilities, we probably want to think of it in terms of a percentage. So we could make it a decimal first, 0.97 roughly. So it's about 97% likely that we'll get at least 1 red out of that batch. So the moral of the story is it would be very difficult to think of all of the winning combinations, but it's pretty quick to figure out the losing combination. So if we can figure out the chances of losing, we can subtract that from 1 to determine what our chance of success is.